Hello everyone, this is Shubham Chaudhary and I welcome you again in the next video of our YouTube channel. So this problem came in 8th of February and we are discussing this medium level problem, perfect squares. Here they have given an integer n and we need to return the least number of perfect square numbers that sum to n. So a perfect square is an integer that is square of an integer. In other words, it is the product of some integer with itself. For example, 1, 4, 9, 16 are perfect squares while 3 and 11 are not, because 4 can be written as 2 into 2, 9 can be written as 3 into 3, it is 4 into 4 and so on. So they are perfect squares. So in the example 1, n equals to 12 and output will be 3 because we can add 4, 4, 4 3 times to get 12 and 4 is the perfect square. So we need to return the least number of perfect square numbers that sum to n. Let's suppose for n equals to 13. So we will add 4 and 9 because they are perfect squares and they are adding up to 13. So we need two perfect squares to do that. So we will return 2 and we need to return the minimum number of perfect squares required to equal the n. So how to approach this type of problem? Let's discuss. So it is a DP, dynamic programming type solution. We will use a DP array for that and we will store minimum perfect square counts. Here we will store minimum perfect square counts and let's suppose we will set base case for DP of 0 equals to 0. Then we will iterate from 1 to n for every iteration. So for each I, we will iterate through the perfect square candidates. So j into j. We will check for every 1 equals to 1 into 1. So 2 into 2, 4. We will iterate through perfect square candidates only. And then update dp of I by taking the minimum of current value and dp of I minus j into j plus 1. From this we will return dp of n, which will represent the minimum perfect square count for n. Using this formula, we can achieve that. So let's code for this solution. Before that, if you are new to the channel, hit the like button and subscribe for more content. So we will initialize a vector of int and we will create a dp array of size n plus 1 with every value as int maximum, means infinity, and then we will initialize dp of 0 equals to 0. After that we will iterate through the for loop from 1 to n and we will increment I, and again we will initialize a for loop. We will implement a for loop for int j equals to 1 and j into j less than equal to I. So we will just checking only for the perfect square numbers. So our j value will be, we will iterate through our j value only for the perfect square numbers which are between I, j equals to 1 to I. So we will check dp of I equals to, we will take minimum of dp of current I value and dp of I minus j into j plus 1. We will take the minimum of this and after that we will return dp of n. By this we will calculate the minimum number of perfect square numbers we need to add to the solution and we will return the dp of n. Let's check the solution. Yeah, the test cases run successfully check for the hidden test cases. Yeah, the solution, the hidden test cases also ran successfully. Talking about the time complexity, so it will be big O of n into square root of n, because we are using two for loops, nested for loops, and it is running in 1 to n, and it is going for the square root of n. Means overall time complexity will be big O of n square root of n, and the space complexity will be big O of n, because we are using this b vector. So that's it. If you enjoyed the video or found it helpful, don't forget to hit the like button and subscribe for more content, and stay tuned for upcoming LeetCode problem of the day videos and exciting monstack web development projects. Happy coding, and let's make this year a fantastic one together. Thank you.